The second concept we're going to look at for Algebra Extension 5 is solving equations with squares. But these are a little more complicated, a little different than the ones that we looked at in class. Remember, in class, we looked at problems like example 1, where our first step would be adding 4 to both sides. We would get 2x squared equals 72. Our next step would be dividing both sides by 2. We get x squared equals 36. And then remember, we're taking the square root of both sides. What we're really asking ourselves is what number could we square to get 36? And we could square a positive 6, and we could square a negative 6. So we need to make sure for this answer that we have both of those, and we could write that as x equals plus or minus 6. Okay, so if we look at number 2, our first job is going to be to get that squared piece by itself. We need to isolate it. So the first thing that we need to do is to get rid of the minus 4. So we're going to add 4 to both sides. And when we do that, we get the quantity x minus 5 squared equals 36. So what I want you guys to think about, first of all, is we squared something and we got 36. That thing that we squared, that would be x minus 5, could be 6 or it could be negative 6. So here's another way to think about that. The stuff that I just highlighted in the parentheses, it could be 6, like we could square 6 and get 6 squared. So x minus 5 could be the same thing as 6, or it could be a negative 6, because we could also square a negative 6. People might write that separately as two different equations. Right? So someone might write x minus 5 could be 6, and x minus 5 could be negative 6. Right? And then you're solving both of those equations. So if we add 5 to both sides, we would get x equals 11. On the second equation, when we add 5 to both sides, we get x equals negative 1. Right, so we have two solutions. One is 11, the other is negative 1. But we could also solve this a different way. We could think about it also as taking the square root of both sides. Remember, squares and square roots undo each other. They're inverse operations. So if I wanted to get rid of the square, I would take the square root. And when I do that, I get x minus 5 equals, now we've already said it could be a 6 or a negative 6. And then sometimes people will write that as plus or minus 6. And then we could actually work that problem with that plus or minus in there. So I'm still trying to get x by itself. To do that, I could add 5 to both sides. And that leaves me with 5 plus or minus 6, right? Remember, that's two different values. So one of them is a 5 plus 6. 5 plus 6 is 11. The other would be 5 minus 6, which would give us negative 1. Notice that it matches up exactly with what we got when we wrote it as two separate equations. And then the last example, number 3, is very similar, only we have more steps to isolate that squared parentheses first. So imagine if this just said like 2p, I'm using the p for the parentheses, 2p squared plus 10 equals 60. If I were trying to get that p by itself, those parentheses by itself, then it's a little easier to see that we should subtract 10 from both sides first. So we're going to subtract 10 from both sides, and that's going to leave us with 2 times the quantity x plus 3 squared equals 50. Again, if that said 2p squared equals 50, it might be a little easier to see that we need to divide both sides by 2. And when we do that, right, 2 divided by 2 is 1, so that just leaves us with x plus 3 quantity squared equals 25. And then we're right back where we were in the problem like number 2. Right? You could either think about it as taking the square root of both sides. Square root of x plus 3 squared is just x plus 3. Remember, the square and the square root, inverse operations undo each other. So for some people, it's easier to think about what that value could be. Right? So x plus 3, the stuff on the inside of the parentheses, we squared it, we got 25. That stuff could be 5 or it could be negative 5. So we could write x equals plus or minus 5. Subtract 3 from both sides, and we would get x equals negative 3 plus or minus 5. Remember, that's two different values. A negative 3 plus 5 is a positive 2. A negative 3 minus 5 is a negative 8. So those are our two solutions for that problem. Again, someone might have decided to write that as two separate equations, right? The stuff on the inside of that parentheses that we're squaring to get 25, well, we could square 5. The stuff on the inside of the parentheses that we're squaring could also be a negative 5. So you could break it up into two equations, solve those by subtracting 3. We get that same 2 that we just got on the second equation. If we subtract 3, we get the negative 8 that we had. So either way, you're coming up with the same solution for that problem, regardless of which of those two methods you use. So now you can go to the practice sheet and try a few on there.